Now we get to the exciting stuff, which is the plastics, which is what brought you here in the first place. Now, since all of the common plastics that we use are thermoplastics, technically we could probably melt them all together to make something, but we choose to separate them. And the reason we do is because you get a higher value material out if you separate them. So on the screen now, you see an odd-shaped block of plastic. And this block of plastic was made by melting a bunch of materials that don't mix very well all together. The shape that you see is in fact the shape of a parking stop. Now, the way this parking stop was made was to take another thing that we don't recognize as plastic, that being carpet, and kind of melt it all together in the way we're talking about in something that can just fill up space and sit in a parking lot. But in fact, this is something that the Tandis Corporation did in its first attempts to recycle its carpeting, as they would simply take the carpet, chop it up, melt it, and create these parking stops. So over the course of time, they developed a process where they could scalp the fiber off the front and be left with the foam backer that they would then add some more post-industrial material to and make a sheet that in fact became the base sheet for more carpet. And in these days, what they will do is when you buy carpet from them, they offer you a guarantee that says when this carpet is worn out, we will take the carpet back and recycle it into more carpet. And in fact, that is what they do. But the thing that's most important to remember about this is if you're going to try to take mixed stuff and melt it together, you're not going to get the best and highest value use out of it. In order to get that, you have to do some separation. Now, what you're looking at in front of you now is mixed, ground-up flake of laundry bottles. Now, what you see here is what it looks like when you melt them all together. Now, let's say for a minute that you were in the business of marketing a consumer product, and you were going to pick the color for the bottle of this consumer product that you're going to put in. Would this color occur to you? The answer is probably no, unless you were going to sell it to the Army. Anyway, this material doesn't have a very attractive color, but that doesn't mean that it can't be used. If you've ever seen the black corrugated drain pipe, then you've seen a place where material like this can go, because it is also high-density polyethylene, just like the laundry bottles, but this black pipe doesn't care what color the plastic was when it started out. And in fact, all it's got to be is long, round, got a hole in the middle, and be able to sit underground. Color doesn't matter. It's not a big deal.
So then, we sort these materials by the type of plastic and maybe also by color. Sorting by color is easy. You just use your eyes. Sorting by material is more of a challenge, but density, will it float, may help us get the job done.
So here's our will it float experiment. I've got a pellet of each of plastics numbers 1 through 6. The first thing I'm going to do is drop them into water. You see, I have 3 of them float, 3 of them sink. We're making good progress. So let's take the 3 floaters, and now we're going to drop them into a beaker of 65-35 isopropanol, that's rubbing alcohol and water, that has a different density than the water. And what we discover is that 2 of them float and 1 of them sinks, so we have the number 2s, the high-density polyethylene, separated out. We're in great shape. Now let's take the floaters, and we're going to drop them into a beaker of corn oil, which has a slightly different density, and what we see is we now have the polypropylene, which is number 5, the low-density polyethylene, numbers 4, and high-density polyethylene, number 2. Those 3 are separated. We've made marvelous. Here's a question for any of you that have ever worked in industry. How do you feel about an industrial process, the last step of which is fish the pellet out of the corn oil? Most people say, not very good unless I'm making French fries, but we're not here. So we're actually not going to use this process to do the separation, except for the water separation. But I've done it here to show you that you can do a lot to separate plastics by physical properties and not necessarily by having to pick them out separately one by one.
But speaking of that, here's a look at state-of-the-art recycling in the last century. Now, this is me working a picking line. Don't be squeamish, garbage doesn't bite. Generally. But you're right, there's a lot of ick factor in picking.
But the principle of that sorting line is if your eye can see it and your hand can pick it, then a machine can probably be devised to do that for you. And that's the next step of the process, the invention of what we call automated sorting. Now, this is a mechanical separation process, and usually it is based on binary decisions of if not this, it's that. And it uses a process that we call spectroscopy, or that's based on different kinds of light that are reflected in different ways from various kinds of plastic. The place you would most often think of what we would call spectroscopy is when you see different colors. It is because you see things that reflect different wavelengths. What we use is the full spectrum of light in order to distinguish one plastic from another, which can be done in the infrared region. And there are other ways in which you can distinguish one plastic from another by using X-rays. In fact, the first automated sorting was done using X-rays, and it was invented by a couple of professors in the physics department at Vanderbilt University. In fact, they took some PET bottles and PVC bottles, both of which are clear, and they took them to the airport and they ran them through the scanner at the airport, and they could see a visible difference in the scanner between the PVC bottles, which looked cloudy because of the chlorine atom absorbing the X-rays, versus the PET bottles, which were clear, which let the X-rays through. That's one way in which you could use spectroscopy to separate these materials. So once you've done that, then all you need to do is to have arrays of sensors that can detect where the bottle is, and a device that knows whether to eject the bottle or let it go on. So imagine that you have a conveyor belt, as you see in this slide. And the conveyor belt runs, and there is a device that senses the bottle that you want. It ejects the bottle up into a remote container, and the ones that it doesn't want just lets it fall into the other container. So we're going to call that the up method. We're ejecting it up in that way. Now, there's another way of doing it, and we'll call it the down method. You see it there on the bottom left. So the conveyor belt runs, the bottle is detected, material is ejected down into a container, ejecting it down, and the other product goes into the other bin. Interestingly enough, if you're a mechanical engineer, you take a look at the up process and the down process, and what comes out the back end is a process where we can integrate both the up method and the down method, and instead of separating two things, we now separate it into three things. We call that a ternary sort. So here's how this whole process comes together. Let's go back to the MRF just for a second. We pulled all the plastics off, and we talked about baling them up and then shipping them off to the plastics processing place. We're there now. But I have to first get the plastics out of the bale, so we use a device called a bale breaker. Now, a bale breaker is not unlike a mechanical metal cat working on your best couch at home, such that it kind of goes like this, and it pulls material off the bale and singulates it so that you're looking at one bottle or one container at a time. The second step is to take the singulated containers and go to a rotating drum called a trommel. Now you'll notice in this rotating drum there are perforations, there are holes. And the reason for that is because the bottles tumble, and dirt and labels and caps fall through, and also the bottles become better singulated for better and better separation. So anyway, now that we have the bottles trommelized, we send them off for the sorting line. And we can first start in this particular scheme with a ternary sort. We'll separate things into natural and opaque colored and clear materials. Now here's an example of how an auto sorting system might work. And what you will see is this conveyor belt is lit. You see bottles come underneath it. The bottles are detected. They get to the end of the line, and then an air ejection either pushes them up above the separator or allows them to go below the separator. In this particular case, we're doing a binary sort. We're separating it in two different directions. Now, this was not a terrible problem from a mechanical basis. The thing that needed to be developed, and the reason why these machines get better and better, is because of the advent of very inexpensive computer power. So now, I've done my ternary sort. I have clear materials, and I'm going to separate the PET from the PVC, so I have 1s and 3s separated. And then if I like, I can take the opaque colored material and separate it into different colors if I want. Or I can just do the crayon experiment again and then grind them all up together and melt them and have it go into pipe. But this is the way the sorting happens, and we wind up with the pure materials, and it really doesn't even involve any corn oil.